Hi, my name is Sana.
I'm Gabby.
And I'm Harrison.
And this is our solubility and equilibrium demonstration.
We'll be forming the precipitate iron hydroxide by the reaction of iron 2 chloride and sodium hydroxide, and then reversing the equilibrium established with an acid.
Throughout this demonstration, we will be illustrating the concept of solubility and equilibrium, as well as Le Chatelier's principle.
First, we start by dissolving the compound iron 2 chloride in water. The polarity of the water molecules are causing the solute to dissociate or separate into its ions. The positive ends of the water molecules attract to the anions, and the negative ends attach to the cations and pull away the cations. Whoa, look at that bright yellow!
The bright color appears because iron is a transition metal, and typically transition metals will form a colorful solution or precipitate.
So now we'll move on to precipitate.
Wait, Sana, don't forget your goggles. Now watch what happens when we add sodium hydroxide to the solution.
What is that?
Sodium hydroxide. A precipitate formed.
The iron ions and the hydroxide ions reacted to form sodium 2 hydroxide, and the compound isn't soluble in water.
So the color change indicated that a precipitate was formed.
Where did the chloride and sodium go? Did it form a salt?
NaCl is soluble in water, so the ions are in the solution.
The solution is saturated with iron and hydroxide ions, as you can see by this equation. The iron 2 hydroxide is at equilibrium with its ions, and this means that the rate at which the precipitate is dissolving is equivalent to the rate at which the ions are forming the precipitate.
Ew, look at that disgusting precipitate. Where's the NJCO?
Wait, what did you just do?
Oh, I get it. Sana used Le Chatelier's principle to shift the equilibrium.
What's that?
Temperature, pressure, and the concentration of reactants and products are the conditions that affect the equilibrium. So, Le Chatelier's principle states that if one of these conditions change, like the concentration of the reactants or products, then the system will shift in order to restore the equilibrium and relieve the stress on the system.
When Sana added the hydrochloric acid, the hydrogen ions reacted with the hydroxide ions in the solution to form water.
But these hydroxide ions were part of the equilibrium.
Since there is now a lower concentration of hydroxide ions in the solution, the concentration shifted and the equilibrium shifted. Le Chatelier's principle stated that if the concentration of the reactants decreased, then the system will shift to restore the equilibrium. So the precipitate dissolved in order to increase the concentration of the hydroxide ions and relieve the stress on the system.